This is the so-called AI powered MediKit. It has lot of features. So this one is for classifying images. When we give an image, it will classify it as a normal or a cancerous one. So what is there beyond classification? So if you look at this is not a normal classification that everyone does. So here I have some images in test data. I'm going to check for this breast. This one is cancerous. This one is normal. The problem in this images is that the features are not evident. These features are very subtle. They require some critical analysis. So if we go with normal classification using some CNN, it may not work well. It may not excel in such patterns because these patterns are not simple patterns. They are very delicate. Now I select this cancer. So this is a cancer's image loaded in and it is classified as cancer. So now if I check here, it is showing like cancer. So if I click on this cancer, it will take me to a page where there will be some description for these kind of cancers and other stuffs. We can follow up with this page. And the classification we have followed here. So as I have said, it is not a normal classification. It is a VAT model based classification. We have a vision transformer that performs self-attention on each patches of images and this classification. So it's not a normal classification, so which may not work on these complex patterns. These patterns are actually not complex but very subtle. So as for the kidney, we have cyst, normal, stone. So the features cannot be found very evidently. If you look at this stone and cyst, we cannot tell which one is cyst, which one is stone. Even a convolutional neural network cannot do in this kind of area. Even some doctors can also fail in these areas actually. So finding the subtle pattern is where we focus on. This vision transformer is good in finding such subtle patterns. Now I open this tumor because some images in stone, cyst, tumor are very similar. So it is classified as a tumor. It's all because of the data set we had and the backbone we have used here. This is actually transformer, vision transformer. It's not a normal classification. And we have a ECG analysis. There are a lot of types in ECG also. Based on these patterns, we can tell what is the behavior of our heart and what's happening in our internal organs. So if you look at these features, look at this pattern, it's not actually, we can note that there may be some intra-class variants because not images of one category are not similar if you look at this one. But this is where transformer excels. When we compare to CNN, this is where transformer excels. So this is classified as a supraventricular beat. So this is very, very important one because intra-class variance is also faced, is also just overcome by this transformer architecture. And now this is prime tumor. These all are actually classification. We can check many like meningioma, glioma, normal, pituitary. I'm not good in biology actually. I'm good in machine learning. So this is pituitary gland cancer actually. We can check which one is this. So this is a pituitary tumor. Yes. And just like that, this is a oral cancer. We can check for oral activities also. This is colon. This is not actually a cancer stuff. This is checking whether it is a damaged part or a normal part. So this is also working well if we just open one lesion. Lesion in biology means a damaged part. Yes, this is a lesion. And we have blood cancer detection. This is very, very important here because the features are very, very, very subtle. This is where vision transformer works, as I have said. So if I look at this is benign, malignant, yearly BP, and this is also malignant yearly. This is malignant pre-B. This is pro-B. Actually, these these are stages. So benign is a beginning stage, malignant is a stage after that. So we can control based on this finding. So by incorporating these stuffs into a medical system, we can make it so efficient. It can actually avoid some manual errors. So this is cardiomegaly actually like focusing on heart, not on heartbeats, but on heart. We have cardiomegaly and normal. The problem is the same stuff. Here we don't have interclass variants. Actually, yes, actually we have interclass variants. We have large intra-class variants, and also the patterns are very subtle. So these are the areas where VAT transformer excel. And this is actually a few shot classification. If I have a tablet, I can show here. I can show here, but I don't have a tablet right now. If I have a tablet, I can show. It will classify. Actually, this is not a normal classification. It is a few shot classification. So few shot classification is where we don't need to retrain our model for new data. Only if we have some data, we just have to add embeddings of this data. It will work. We don't need to retrain our data, retrain the model to classify the data. And this is heartbeat analysis. So what we have done there is extracting the MFCC features, and based on that we perform classification. Based on the beat of the heart, we can tell what is the behavior of our system. So this is abnormal beat. We can pause by pressing P. So we also have some murmur. These are some stuffs. And we can also tell some eye diseases can be also classified. Just look at this retina disease. They all look similar. Somewhat they are similar, but they can be classified. So that is actually the challenge. That is actually the challenge that was faced by our vision transformer. We have lungs, for which we have the classification stuffs like corona, normal, tuberculosis, viral pneumonia or bacterial pneumonia, and also for bone, whether it is fractured bone or not, because this is quite important. If we just look at some, I think I don't have bone images here. Yes, here it is. So this is fractured. How can we check this is fractured? If I open this image, if you look at this, here we can see it is a fractured bone, but it can mislead us, it can deceive us, because that feature is very, very subtle. If I open some other not fractured stuff, it cannot be like that. This is a not fractured bone. If you look at this, there is no fractures. And we have herb. If I want some herbical solution, what happened to me? Like I have fever and cold. Okay. So it will take us one herbical solution. It will give a herbal solution. We can use this Tridax-Stacy to cure the condition. Tridax-Stacy can be used to cure this condition. Also, we have some other herbs also. They are updated in a meta file, meta.json there. So it is not a classification, it is a text similarity search. So inside this AI powered medikit, we have incorporated classification using VAT transformer and its advanced state of the art self-attention mechanism rather than rely on convolutions. And we have also incorporated some MFCC based classification on this heartbeat analysis. And in this tablet, it is a few shot classification, not a normal classification. We can classify more tablets. Yes, and we have this herbical solution. This is a text similarity search actually. So we capture the minute features. There are subtle features in medical images. So medical field is where data of subtle features is generated. So this system is designed for classifying such patterns, because some normal CNN may fail on classifying such stuff. And also, this is our compact AI powered medikit. Thank you so much for listening.